Okay, welcome to second long episode of Boxroom Mathematics. This is the Boxroom. The mathematics we're looking at is Leaving Cert high level papers. So this one, you'll need the exam papers to follow this video. We're looking at 2019 higher level paper 2. Okay, let's get going. So the big thing we want to focus on all the time is kind of a mixture of, just understanding the maths quite well, doing the maths properly, but also kind of exam technique in the sense of answering the question that was asked and does your answer make sense. These are probably the big things that we're going to be focusing on here. Okay, so the first thing is we've got a class consisting of 12 boys and 8 girls. So 12 boys, 8 girls, and the question is 2 students are selected at random from the class. What is the probability that the 2 students selected will be a boy and a girl in any order? So I'm not sure what the textbooks and what the teachers are doing here in terms of notation, but for me what I want to think of is probability is a function from events, which are kind of combinations of outcomes to numbers between 0 and 1. So in this case, I'm interested in the probability of getting 1 girl and 1 boy, which I'm just going to write like this. Now there's 2 ways that this can happen. So it'll be girl-boy or boy-girl. Okay, so you're looking at the probability of girl-boy or boy-girl. Now one of the things about probability, when you have events that are called mutually exclusive, which means they can't happen at the same time, you can't have these 2 happening at the same time, then the or means plus. Okay. Now here, the event of picking a boy after picking a girl, they're what I call non-independent, so we will be multiplying the probabilities, but it's not going to be the probability of drawing a boy, it's going to be the probability of drawing a boy given that you've drawn a girl. So how this is calculated, so the probability of taking a girl here is 8 out of 20, and then multiplied by the probability of choosing a boy given that you've just drawn a girl would be 12 boys, but because a girl has already been drawn, this isn't divided by 20 but 19. And similar story, boy then girl, the probability of boy is 12 out of 20, and then the probability of a girl is 8 out of 19. And so this looks like something like 96 over this plus 96 over this. So it's 2 by 96 over 20 by 19, and 2 divided by 20 is a tenth, and then I could also divide above and below by 2, I get 48 over 5 by 19 is 95, and I'm fairly sure they don't have any more factors. Of course you can go into the calculator there. Okay, so that's the question done, but so what I'm focusing on is, did we answer the question that was asked? Did we find what is the probability that 2 students selected to be a boy and a girl in any order? We did that. And does the answer make sense? It's very possible you make a small mistake, for example a calculator mistake, and say for example you ended up somehow with 95 over 48. That answer would not make sense because probability is a number between 0 and 1, and that will tell you that you need to go look back at what you did. Okay, question 2. Question 2 says, and as I said, you want to have these questions in front of you. 4 students are selected, 1 at a time, at random from the class. what is the probability that the first 3 students selected will be boys and the 4th will be a girl? So it's going to be actually a kind of a similar question. We're looking at the probability of boy, 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 and then after that a girl. Okay, so again, so this is called sampling without replacement. Once we get a boy out, there won't be 12 anymore, there'll be 11. So the first is 12 out of 20. Then one boy missing, no longer 20 pupils, there'll be 19, so it'll be 11 out of 19. And then similar story, 10 out of 18. And then the girl, 8 out of 17. And the question is, okay, so we probably just go to the calculator with this. I could do, maybe I'll do a bit of simplification here. So if I divide above and below by 10, that'll be 1 and that'll be 2. Divide above and below by 2 here, this will be 6 and this will be 1. Divide above and below by 6 here, this will be 1 and this will be 3. Have I anything else here? Well, these are prime numbers, 19, 3 and 17. And this is multiples of 2, multiples of 11, so I can't do any more. So I end up with 11 by 8 is 88. 3 by 17 is 51, and I'll just go on the calculator by 19, 19 by 51. So I end up with 969. Have we answered the question that's asked? Yes. Okay. There we go, that's that question done. Not too bad to open it. Okay. Question B. So this one says an examination paper is made up of 2 sections. Section A consisting of 7 questions. Section B consisting of 8. And the paper contains the following instruction. From section A you must answer question 1 and 3 more. From section B you must also answer any 4 questions. Find out how many different combinations of questions may be answered if a candidate follows this instruction. Okay, there's not two, so what you have to do here, so there's no choice in the first question in section A, so you may as well kind of forget about that. So the choice consists of, from the 6 questions 2 to 7 in section A, you need to do 3. So from 6, choose 3, and then from B you need to do 4 questions. From 8, choose 4. Now the number of ways of doing a series of tasks is you multiply together the number of ways of doing the constituent task. So to last question, how many different combinations of questions? Well, you must make this choice, how many ways of doing that, and then you must and do this, and the and means multiply. In a similar story, that and means multiplying probabilities, kind of similar reasons. So here we're getting that the number of choices, so the number of combinations, I'll just say number of choices, combinations, equal to. Now, how many ways from 6 can you choose 3? It's 6, choose 3. I'm not sure how you write it. Do you write the 6 and the 3 in the big brackets? Or you can write it as 6, choose 3, multiplied by 8, choose 4. And we'll do that on the calculator. Let me see. 6, choose 3, multiplied by 8, choose 4. And I get 5,880. Okay, that seems to be a question done, not too bad. Okay, no bother. Question 2. Okay, what do we got here? So we got a little picture. The line P makes an intercept on the x-axis at A0 and on the y-axis at 0b. Show that the equation of P can be written in this form. Okay, so basically what we're asked to show, now I'd say one thing that is important, it said neither A nor B are 0, so it's giving us, there's various different ways of doing this question. So it cuts there at A and it cuts there at B. and it wants us to show that it can be written as x over a plus y over b equal to 1. So there's probably two main ways of looking at this. Oh yeah, the line is the one that goes through the two of them. So the two options would be that you find the slope of this line and you take one of those points and you do your y minus y1 is equal to m times x minus x1. That's one option. Personally, I prefer y equal to mx plus c. I think all the time actually y equal to mx plus c is the thing that it should be more in the leaving certain it isn't. So let's rock with y equal to mx plus c. Now y is y, m. So now as it's drawn, does it say anything about a and b being positive? No, it doesn't. Now that gives a possibility that what we're doing is a little bit dodgy. Because what I want to say here is that the rise over the run, so say you go from here to here, the rise is minus b and the run is a. And I would write that the slope is minus b over a. That's possibly a little bit dodgy here because it's dependent on how the picture is drawn. Yeah, it's a little bit dependent if a and b are positive. So I'm going to go back and I'm going to use the slope formula, which is the y2 minus y1. So this is a0 and this is 0b. And I'm going to say this is the second point, this is the first point. So y2 minus y1 would be b minus 0 over 0 minus a. And that just shows that the minus b over a is actually correct no matter what a and b were. Times x plus, and then c is where it cuts the y-axis, which is b. Okay, so what we have is y is equal to, now b over minus a is minus b over a, x plus b. Now what we want to do is write it in a particular form. I think it's called the intercept form. X over a plus y over b is equal to 1. Now strategically what you want to probably do is, if you look at the equation there, it's going to be difficult to kind of get it around from here, but I suppose you could try. I'd probably think of adding the minus b over a x to both sides. Excuse me, not the minus b, adding plus b over ax to both sides. And I would end up with b divided by a times x plus y is equal to b. And here it should be reasonable enough to see that if you divide both sides by b, you'll get what they're looking for. So divide both sides by b. Okay, so here you've got x divided by a and multiplied by b. But if you do b divided by b, that's just 1. So you got x divided by a multiplied by 1, which is just x divided by a. Now if you've got a sum here and you're dividing it by b, you divide everything by b. So this is plus y over b. And then b divided by b is equal to 1. Not too bad, okay. Is that done? Part B. So it says the line L has slope m and contains the point 6, 0. Write the equation of the line L in terms of m. So there's probably different ways of going about this as well. So I suppose okay, so the one thing that I would add is, especially in paper 2, well also in paper 1 to be quite honest with you, is draw lots of pictures. Because in maths, what you have is you've geometry, which is pictures, and algebra, which is what we're doing here, and they're both sides of the one coin. So if you're any bit of doubt, you're perfectly entitled to start drawing pictures. Now I don't think it's completely necessary here, and I think what this question, it's a little bit funny. I think it's actually about, if you got a tool, you don't have to use it. I think you're kind of tempted to use this on this question here, but actually this doesn't really help you. So what we have is this. Now you can write this as C if you want, but and it's just saying that the slope is m. Yeah, I don't really know what they want us to do. I mean, we have a point and a slope. Seems pretty straightforward. So yeah, I think we're just going to actually not use this. We're just going to use y minus y1. I don't understand what this question is about really. So we got y minus y1, the y1 is 0, is equal to m times x minus x1, which is 6. So I'll add the 0, you don't have to do that because it's just y minus 0 is y. Y is equal to mx, or even m times x minus 6. Perfectly good answer. Have we answered the question that's asked? Have we written the equation of L in terms of m? Yes, we have. Okay. Okay, what have we got here? So the line L cuts this other line at a certain point. Find the coordinates of P in terms of m. Give each coordinate as a fraction in its simplest form. Okay, now there is going to be something interesting in this, which we'll get to. So this is the first line. This is line L. And the second line is K, which is given as 4x plus 3y equal to 25. And it's telling us that P is the intersection point. And what we want to do is we want to find the coordinates of P in terms of m. Now, as it happens, there are values of m that these don't intersect. So you can find the slope of this line here, and if m has the same slope, it's possible that they're parallel and they have no intersection. So this is something that should come out in the maths, which will be a little bit careful with. You need to understand that every point on a line satisfies the equation. So say if this is the line M and the line K, suppose that looks something like this. Every point on this line satisfies this equation. Every point on this line satisfies this equation. The point here is on, which you could call the intersection, L intersection K, is a point on both lines, so it satisfies both equations, so you're talking simultaneous equations. Now if you want, you can do your kind of row stuff, you know, where you kind of get similar multiples of x and y, but I think it's easier just to substitute, and this is a general strategy in solving simultaneous equations is substitution, so why not do it for lines as well? So we're just going to substitute this, in other words this, in for this, and then we'll have an equation in x in terms of n. It'll be something to look out for, which we will see. Okay, so we have 4x plus 3 times y, but we know that y is equal to m times x minus 6 equal to 25. And we want to solve this for x in terms of m. So I think the easiest thing to start here is to multiply out this thing here. So we get 4x plus 3mx minus 18m is equal to 25. Now what we want to do is we want to solve for x. So what you need to do is you need to get this 18m out of there. So the inverse of subtracting minus 18m is adding 18m. So we're going to do that to both sides. 4x plus 3mx equal to 25 plus 18m. And now what you want to do with the left hand side there is, if you're hoping to solve this for x, and now if it's 4x plus 3x, you've got no issue, you just say 7x. It's a bit more complicated with the extra variable m there. So what I recommend here on the left hand side is you take out the common factor of x. And you can do this with 4x plus 3x, it's just kind of an overkill. You'd end up with x times 4 plus 3, which is x times 7, which is 7x, which you would have done quickly anyway. Okay, so take out the common factor of x, and I have 4 plus 3m equal to 25 plus 18m. Okay, so excuse me. Now this is a place where you can get into a little bit of trouble, and we'll see this. The paper might see this. So something that you not always should be aware of, but it's out there. Just like you've got an issue with the square root of a negative number, you've an issue with dividing by 0. So if I want to get x on its own here, I need to divide by 4 plus 3m. But if this thing is equal to 0, I can't divide by it. Okay, so I've got this x multiplied by this, so I must divide by it. But I just must be careful that it's not 0. So I end up with an expression for x in terms of y, 25 plus 18m divided by 4 plus 3m. Now I'm just going to make the remark, 4 plus 3m cannot equal 0. And that's the same as saying you don't want 4 plus 3m to equal 0. So you don't want, so take away the 4 from both sides, you don't want 3m to equal minus 4.